Welcome to the tutorial Handling of the data logger as a ring buffer with the easyE4 using the ST programming language. In this example, a pump station with two pumps is simulated. The data logging is to record the level of the water tank, the status of the two pumps and the water pressure. The following technical requirements must be met. An easyE4 basic device with firmware version 2.0 or higher and hardware version 0.8 or higher, the easySoft programming software version 8.0 or higher. A license is required for the easySoft programming software. Software, firmware and updates can be downloaded from www.eaton.com/software. An SD memory card, an EasyCom SWD-C1 module. This module is not required for using the data logger, but is used in this example. Now, what does the mechanical structure of the prepared exemplary application look like? An easyE4 UC12RC1 with firmware version 2.0 is the basic unit. The pump station is simulated on a training board via the EasyCom SWD-C1 module using the SmartWire DT communication system. Additional information on the communication system is provided in the video tutorial SmartWire DT Overview and How to Use in easySoft 7. The pump station is switched on with station C1.2 via button S1, I18, and switched off via button S2, I17. Operation is indicated by LED P1, Q19. Device C1.3 with switch S3, I19 simulates dry running of the pump. LED P2, Q20 signals an error in the data logger. Device C1.4 with button S4 resets the marker words for level and set point pressure in this simulation. LED P3, Q18 signals the operation of the booster pump. Device C1.5 with potentiometer R1 IA05 sets the set point for the simulated water pressure. Finally, device C1.1 controls the pump via the MSC DEA motor starter with an electronic motor circuit breaker PKE I20 and a contactor DIL M7 Q17. Motor current simulation is not used for data logging in this example, nor is the LTE gateway for a cloud connection to BrightLayer. The XN322-5ETH UMS industrial switch mounted on the right side is used for communication between the PC, the easyE4, the LTE gateway and two other possible devices. Some short comments on the created program with structured text ST. For the markers, marker bytes and marker words used, non-overlapping ranges were deliberately chosen, as can be seen from the displayed graphic. Therefore, the first marker word with MW257 was selected. Exception. For the data logger, no marker bits can be applied to the analog inputs. Here the marker bit M17 is the first bit in the marker byte MB3 and the marker bit M25 is the first bit in the marker byte MB4. A fixed cycle time of 200 milliseconds is specified for the simulation via the ST set cycle time function block. The following if instruction switches the pump station on and off. The pump is switched on and off depending on the simulated fill level of the water tank. The simulation of the fill level is then achieved in the next if instruction by incrementing and decrementing marker word 257. The handling of the supporting booster pump takes place depending on the control difference between the simulated actual value water pressure and the set point value water pressure. To prevent permanent switching of the booster pump, a hysteresis is programmed in here. For the simulation when the booster pump is switched on, the marker word 259 for the actual value of water pressure is incremented by 10, and when the pump is switched off, it is decremented by 1. Without booster pump and pump switched on, the actual value of water pressure increases by 1 increment per cycle. The next if instruction deals with error generation while processing the input for dry running and the status of the motor protection switch PKE. The text display block supplies the status information of the pump station, the filling level of the water tank, the water pressure actual value, the water pressure set point, the here simulated motor current, and the error display with their respective assigned operands. The last function block in this program is the data logger. Each easyE4 contains a maximum of one DL01 data logger, which can be found in the group of function blocks. This function block can be used to write operating data with a timestamp to a log file on the SD memory card in the easyE4 basic device. An inserted memory card is always required in the device for operation of the function block. The function block can be labeled with an operand command for easier identification. In this application example, the EN enable input for activating the data logger when the pump station is switched on is set to true. For this, the corresponding box for the function block enable must be also activated in the configuration of the function block. If this selection has not taken place, the data block is always enabled. The EN input is ignored. The file name on the SD memory card can be specified during parameterization. A maximum of 8 characters, capital letters, numbers and some special characters are permitted. These must conform to Microsoft's DOS conventions. If no file name is assigned, the default file name is EasyLog. Ring buffer is selected as the storage mode in this example. Some explanations about the operation of the ring buffer. The maximum number of datasets in ring buffer storage mode can be calculated as follows. Number of files per log session, for example 3, multiplied by number of datasets per log file, for example 100, minus 1 dataset. With these sample settings, a maximum of 299 datasets can be made available in the CSV file that is read out. If the next single trigger for data recording is set, 201 datasets can be read out afterwards. The first 100 old datasets were overwritten. If you change the default number of files per log session to 100 and number of datasets per log file to 3, this changes as follows. With these values, a maximum of 299 datasets can also be made available in the CSV file that is read out. However, with the next single trigger for data logging, 298 datasets can now be read out. Only the first 3 old datasets will be overwritten. Depending on the application, a balance ratio between number of files per log session and number of datasets per log file should thus be selected to increase data security. The user always sees only one CSV file when reading out the SD card, regardless of the above setting. A note: the existing log file continues to be used even when the EN input is changed, when the easyE4 is stop and run, and when the easyE4 supply voltage is switched off and on again. A new log file is generated when a new program or a program update is transferred to the easyE4, when a log file is read in run, or when restart is selected in the communication window of the memory card. Each new log process starts with 0. Data recording can be triggered as follows: by a rising edge of one of the trigger inputs T1 to T4, by a parameterizable data change at the analog function block inputs I1 to I4. If the data change is 0, there is no trigger. Several trigger events can also occur at the same time, regardless of whether via T1 to T4 or via I1 to I4. With the detected trigger, both the trigger inputs T1 to T4 and the analog inputs I1 to I4 are recorded. For data recording, it doesn't matter which input was used to generate the trigger. The analog inputs I1 to I4 can be assigned any byte, word or double word operands. In this example, the simulated level of a water tank, marker word 257, is continuously recorded via delta I1 of 1. With real analog inputs, however, a larger delta should be set here to avoid triggering unwanted data recordings. Inputs I2 and I3 read the states of the pump and booster pump, calibrated to 100% and 50% respectively. Input I4 records the actual simulated water pressure, calibrated to 100%. E1 error output of the data logger, which reports data loss, is a diagnostic option. This output is assigned to the digital output Q20 LED P3. The possible causes for errors are shown as a screenshot. Alternatively, the diagnostic bit ID 18 can be used to check whether the SD card is plugged in. Finally, a sequence for zero setting the water level and the actual value water pressure was inserted at the end of the program for the simulation. The online connection to the easyE4 is established. The program is switched to the online view for tracking. The recording of the data logger is activated when the pump station is started. With the new hardware version 08 and firmware version 2.0, it is now possible to read out the recording of the data logger also in the run mode of the easyE4. To read out the SD card, exit the online view and select Card button. To query without stop of the easyE4, the next query must be answered with No. The data logger recordings can then be called up via the Card to PC button. The current status of the SD card is displayed in the window that appears. As already mentioned, if no file name was assigned during the configuration of the data logger, the name EasyLog is used, as can be seen from the first entries listed. Since in the run mode the memory content of the SD card is requested, a 0 comes as entry of the datasets, since the log file is still used for the recording. When this file is selected, the next query therefore appears asking whether a new recording should be started, which is answered with yes. The selected records are saved as a CSV file in the desired folder. When opening the CSV file, you see in the first columns the continuous counter, the date and the time, plus separate indication of the milliseconds. The trigger inputs are not used, therefore there are only data entries in the columns for the analog inputs I1 to I4 of the data logger. As an example, a line diagram is created here in Excel, based on the read-in data. Further recording is made to show the difference to the data readout in run. In order to always write to the same CSV file, the readout in stop mode of the easyE4 is selected with yes in this case. Instead of 0 datasets in run mode, 201 recorded datasets are now seen in this example. The CSV file pump_001 is saved in the desired directory. Since this is a new recording, the counter of the CSV file starts with 0. In this case, the last record in line 202 of the CSV file is 200. Also, the first record in the third log file, with the selected setting 3 files per log station and 100 datasets per log file. For data recording in the same CSV file, the easyE4 is set to run and the simulated pump station is restarted. Here too, the easyE4 is set to stop to read out the datasets. There are now 214 datasets on the memory card in the pump_001 CSV file. The CSV file pump_001 is to be kept in the selected memory location and is therefore overwritten. With the opening of this file, you see now that with the selected storage mode ring buffer, the datasets 0 to 99 are deleted. The new recording begins in line 113 with 0 and the 214th entire dataset ends in line 215 with dataset 102 from the new recording. A note at the end. If an SD card is to be read out without an existing easyE4, this is possible by using an SD card reader as follows. The SD card is inserted into the card reader connected to a PC. In the project view, either switch to the SD card sub-item in the project menu or select the SD card icon directly. In the menu that opens, Card Setup, the storage location of the SD card is to be selected at the top right, which has already taken place here. When selecting the storage location, it is important to select the main path of the card and not the lower level log folder. The desired log files can now be accessed via card to PC. Thank you for your attention.